It's good to come your way once again as we continue this wonderful and exciting journey in additional mathematics. We are considering functions, and we have looked at a series of lessons where we have looked at functions. We've considered why we must study functions. We have looked at the vertical line test of functions, and we've considered how we can evaluate function. My name is Nana Yawedu, and you can call me Sir Nana. Remember to like this video, share this video, subscribe to my YouTube channel, and don't forget to click on the notification bell so that you can get all the videos on time. In this lesson, we want to consider the domain, and then we would link that with the range and the zeros of a function. But we'll focus on the domain of a function. So let's consider this function. I'll give you a very interesting scenario so that you'll be able to understand what these things mean when we say something is a domain and something is a range. I believe in previous lessons I've been mentioning them, and then I'm sure you might have heard of it, right? So let's consider that these numbers are codes, right, that have been used or generated in a game prepared by you yourself. For some of you, you do IT or elective IT. So this could be code, right? So the X values represent countries. So let's say that the 1 in the X value represents Ghana, our home motherland, right? And then the 2 represents Cote d'Ivoire, right? And then the 3 represents a country, let's say Netherlands. And then the 4 here represents South Africa, right? And let's assume that the Y consists of the capitals. So capitals could be anything, including the capitals of these countries that we have. So we can have 8 probably representing right, the 8 maps to the 2, so the 8 represents Abidjan, right? So let's do the right thing. So the 8 represents Abidjan, right? And then we have the 1 going with 1 here, so the 1 in the Y would represent Accra, right? And then we have the 4, which is South Africa, so the 64 represents Johannesburg, right? And then we have the 3, which goes to the 27. The 27 represents the capital of Netherlands, which is Amsterdam, right? So that is Amsterdam. Very good. Now we also have some other ones like this. So I'll mention 1 or 2. So we have the 3. Basically, let's say it represents any capital at all, like Lomé. And then so does the 16 and the 2, the 4, the 9, right? And the 23 represents other capitals, right? So we can say that the X, right, which represent the countries, represents our domain, right? So we now see a domain. So the domain represents basically our values which are in one form or one part of a function whose image, right, can be found. Whose image can be found. So the images are the capitals. So you prepare a game where you have these 4 countries, and then you put a lot of capitals in the game, right? So you program the game, you put it in a programming language, so that what is a country or what is a capital of a country called Cote d'Ivoire, right? So you are expected to provide an answer, and the answer you provide should be within the range, right? And specifically, it should be the range, right, for Cote d'Ivoire is 2, so it should be 8 specifically, which is the Abidjan. So once you select anything outside that, the programming language is able to tell you that no, this is wrong, and indicates it through the software that you have a wrong answer. So the range of a function represents the images, the various images of the domain that we have found, right? So these yellow ones represent the range of the functions. Now, all the possible capitals that we can have or that you have inputted in the game will represent your codomain, right? So when we talk about domain, we talk about the range, and then we talk about the codomain. We see how practical these things can be. So when we say a domain of a function, we say that the domain of a function, say f of x, is a set of all values of x which can be evaluated. So as we said, in terms of mathematics, we evaluate. So for instance, if I have f of x is equal to 3x, all the values that I can put in place of x is the values that I can evaluate, right? Which can be evaluated, and hence its image, right? So for instance, if I say x is equal to 3, then I know f of 3 will be equal to 3 multiplied by 3, which gives us 9. So this is the image of 3 in the 3x in the function f of x, which its image, right, under the function can be obtained, right? So for example, for f of x, f of a, where a represents what? Any element in the set D, can be evaluated, then the domain of the function f of x is D, right? So that is the domain of a function. So we have different types of functions. For instance, we have polynomial functions which are written in the form y is equal to f of x, right? So when we see a function f of x is equal to 2x plus 1, or y is equal to 3x minus 3, which is a linear one, right? These are linear functions. Or we see f of x is equal to 2x squared plus 2 plus 1, right, which is quadratic. All these functions are polynomial. And we realize that for all these functions, any value that you put into in place of x, which is in a real number system, right, will give us an answer which is in a real number system. So when we put, let's say, square root of 2 in the function here, we are going to get 2 square root of 2 plus 1, right? And we can evaluate this to get a decimal, which is the real number system, right? Or when we put, let's say, 1 over 2 in place of s, we'll get 2 multiplying 1 over 2 plus 1. This will cancel this. We have 1 plus 1, which is equal to 2, which is also a member in the real number system. So we say that the domain of this function, right, the domain of this function will be in two-set form x such that x is a member of all real numbers. So any x which is a member of all real numbers, when we put it into the function here, we get the domain of the function, right? Means that that function, the image exists. So we say that this constitutes the domain of the function, right? How about when we have a rational function? So rational functions are functions that are of the form y is equal to f of x all over g of x. So we have y is equal to 3x minus 2 all over x minus 2. So this is a rational function. So to find the domain of a rational function, remember that when we punch or when we type 3 all over 0 in the calculator, we get an undefined term, right? We get an undefined term because 3 over 0 does not belong to any member of the real number system. 3 over 0 is not a subset of the real number system. It doesn't belong there at all, right? So to be able to find the domain of the function, we know that this function would be x such that x is a subset of all real numbers, but then the denominator here cannot be 0. So it means that you must take the denominator x minus 2 and equate to 0. It means that x will be equal to what? 2. Then we say that except x is not equal to 2. Because when x is equal to 2, then it means that we will have 2 minus 2, which is 0, and that makes the function undefined. So the domain is a set of all real numbers, but then x should not be equal to 2, right? So if you have a rational function, equate the denominator to 0, and then write the all real numbers except the number that you get for the x value. Right, now how about when we have a radical function? So radical functions are functions that are in the form f of x is equal to square root of, let's say, 3x minus 1, right? So a radical is in a square root. Now we know that we can have the square root of a negative number. So for instance, square root of negative 2 within the real number system does not exist, right? When we punch this in a calculator, it also gives us mass error in some cases, or an undefined term, right? But then we know for this, when we move on in mathematics, we can see that this can be a complex number, or we can express this in a complex number form, but it doesn't exist in a real number system. So what we need to do is that x should be greater than 0 for the functions in the square root to be defined. So take the functions in the square root or the numbers in the square root and let it be greater than 0. So 3x minus 1 is greater than 0. So 3x will be greater than 1, right? When we move 1 across the equal sign, then we divide both sides by 3, right? So it means that x is greater than 1 over 3. So we can say that the function here, right, it is going to be real, all real numbers, s is such that x is a subset of all real numbers. That is a domain, right, except or where x is greater than or equal to 1 over 3. So the 1 over 3 is inclusive because when we put 1 over 3 here in place of this, it makes the function square root of 0. And square root of 0 is 0, right? So it means that 1 over 3 is inclusive. That's why we brought or equal to. So the domain will be the set of all real numbers, but then x should be greater than or equal to what? 1 over 3. So if x is less than 1 over 3, what happens? You realize that the function becomes what? Undefined, right? Or there is a mass error. So that is for radical functions. And then for exponential functions, any value we put here, which is in a real number system, will make the function defined. So we have s such that s is a member of all real number system. Means that s can be anything in the real number system and we'll be able to get a value for the exponential functions. And then we have logarithmic functions as well, right? For logarithmic functions, we can have a negative value, right? When we have log of negative 3, right, we can get this. This in the calculator would also give us an undefined term, right? So we see that for this, s is such that x is a member of all real numbers where x is greater than or equal to 0, right? So x should be 0 and above, right? S should be positive integers. So that is for logarithmic functions. So these are the domains for the various types of functions. We have looked at the domain of a function. We've considered the domain for the various types of functions. In our next lesson, we want to consider how we can find the range of a function. Remember to like this video, share this video, and subscribe to my YouTube channel. See you in the next lesson.